Right, so this is 8.5 geometric series, which is where we're going to be adding up the terms in a geometric sequence. Because remember, all a series is a summation. Another word for series would be a summation, where we're adding up the terms. And I like to introduce geometric series with this story that has to do with the king of Persia. He got to meet the guy who invented chess, and he just thought that chess was the coolest game ever. And so what he did was he offered to the man who invented the game of chess, he said, like, you can have anything you want, anything at all, I'll give it to you. And so the guy who invented chess, of course, he didn't just say something simple. He had to make what he said something that the king would have to think about. And he said, okay, what I want is I want a piece of grain on the first square of the chessboard. And every square after that, I want you to double how many heads of grain there are. And the king of Persia was like, what? That's it? Sure, okay, you can have that. Now, of course, the king wasn't thinking about the fact that he didn't do the mathematical problem to realize what it was that the inventor of chess was actually asking for. So if we have one head of grain here, we're going to write everything to a power of 2 because we're going to be doubling everything, so we're going to keep multiplying by 2. So in this first square, I'd have 2 to the 0, which is 1. And then here I'm going to have 2 to the first because I doubled it, so I went from 1 to 2. Then I double that, so it becomes 2 to the second. I double that, then that becomes 2 to the third because I just keep multiplying by 2. Because this is 4, this is 8, multiplied by 2. That gives me 16, or 2 to the fourth. And I just keep going up like that, and it's going to just keep going. And it's going to keep going all the way till I get to this very last square, which is 2 to the 63rd. It's not 2 to the 64th. There are 64 squares, but the first one was 2 to the 0. So this last one is 2 to the 63rd. And I have to add up all of these, which means I am adding up from n equals 1 to 64, or actually I'm going from, well, no, I can say 1 to 64. The first square has 1 on it, and then I'm multiplying it by 2 to the n minus 1. Because I'm just going to go from 1 to 64 and say, okay, what's happening is I'm doubling it. So I'm multiplying it by 2, and I have 64 squares on the board. So I just have to add up all these numbers. Well, that's a lot of numbers to add. So just like I did with arithmetic series, I'm going to need a formula for a finite geometric series. And so my formula for that is going to be S sub n is the sum from 1 to n of g sub 1, the first term, times r to the n minus 1, which is g sub 1 plus g sub 2 plus g sub 3, all the way to g sub n. The formula for that geometric series is g sub 1 times 1 minus r to the n divided by 1 minus r. Now notice the n here is only on the r. It's not on the outside of the parenthesis. A lot of people want to put it out there. It's not. And make sure when you divide, it's 1 minus r. Not You've got to make sure you have parentheses around this, okay? So let's look at, let's use that actually for the chess example, okay? Let's see how many heads of grain that would be. So my first square has, so let's see, g to the 64. I'm sorry, not g to the 64. I meant to say s sub 64 is the first term, which would be 1 head of grain, okay? 1 minus, my common ratio is 2. Right there, that's my r. And that's going to be to the 64th power, not to the 63rd. Notice these match. This says, this should say S sub n. These match. You don't subtract 1. This is 64, this is 64, all over 1 minus 2. Now I'm going to go ahead and rewrite this. I know that I'm multiplying by 1, so it's just going to be 1 minus 2 to the 64th. All divided by 1 minus 2 I know is negative 1. Now I could leave it like this, or I could simplify it like this. I'm going to show it to you in the calculator. All right. So I'll do it the first way, 1, and then in parentheses, 1 minus 2 to the 64th. Okay, that's what's in the numerator. I hit enter, and then I divide by, in parentheses, 1 minus 2. And I get 1.8446744407 times 10 to the 19th, which means I'm going to move this decimal 19 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, and add 10 zeros. So that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have no idea how you say that number. That's a really big number. Now, the king of Persia thought this wasn't a big deal when the inventor of chess asked for this. But what he didn't realize is that he's going to control all the grain. Well, if you control all the grain, you control the food supply, you control the country. So the inventor of chess was obviously a very smart person. Okay. If I had wanted to simplify it like this, I could have put in parentheses 1 minus 2 to the 64th divided by negative 1, and I still get the same answer. So I could have put it in either way. Let's go to my examples down here. So this is going to be the formula for a geometric series. In the last section, we learned formulas for arithmetic series. This is the formula for geometric. This is a geometric series. We're asked to rewrite the series using sigma notation. So this is sigma. So n equals 1 to, let's see, 1, 2, 3, 4, 5, 6 terms. The first term is 6. I'm multiplying by something n minus 1 times. So I need to find my constant ratio. So remember, ratio equals term divided by previous term. So r is going to be, I could say 4 divided by 6. I could do 2 2/3 divided by 4, or 1 7/9 divided by 2 2/3. I think this is the easiest one to put in my calculator. So 4 divided by 6. I'm going to convert that to a fraction, 2/3. So my constant ratio is 2/3. So that's what's going to go right there. That's converting this series to sigma notation. Now we're asked to evaluate the series using the formula. This is my formula for the sum of a geometric series. So S sub 6 equals the first term, which is 6, 1 minus 2/3 to the 6th power. Notice these should always match, all divided by 1 minus 2/3. Now, I will be honest with you, I usually do this in my head. I know that 1 minus 2/3 is simply 1/3. So then I go to my calculator, 6 parentheses, 1 minus the 2/3 is what's getting raised to the 6th power. So all of that is my numerator, divided by my denominator, which is 1/3, that I have to protect with parentheses. All right, and I get 16.42. Okay, I can do math, enter, enter, and I get 1,330/81. So there it is as a decimal. Here it is as a fraction in lowest terms. Let's go to our next one. I'm going to rewrite my formula. S of n equals the first term times 1 minus r to the n all over 1 minus r. Notice these match. This is n, this is n. It's not n and n minus 1, it's n and n. Let's look at this formula here. So S sub 6 is the first term is 24. And I know this is the first term because it says I minus 1, and it doesn't just say to the n or to the I. 24 times 1 minus, this is my constant ratio, 1/3, to the 6th power. These should always match, all over 1 minus 1/3. Again, I always do this step in my head, and I simply know that 1 minus 1/3 is 2/3. And this is the point at which I get out my calculator. I'm going to do 24, parentheses 1 minus, I have to protect that 1/3 with parentheses to show that that's what I'm raising to the 6th power. And then I divide that by, in parentheses, 2/3. And I get 35.95. See if that can be a fraction. Or 2,912/81. Okay. This next question, I think these last two I will do on our next video.